Budget drill planning. What is that like? Why is that important? But first, that's standard Datamine plug. Just who is Datamine? What do we do? We're an integrated solution provider for the entire mining value chain. If you didn't know that already, most of you calling in would be on the geology space, but we do actually have quite a bit of other solutions as well. Today, we're going to be talking mostly about Studio RM, but the Studio Core functionality is carried through quite a few of the other softwares. If you're in exploration, you do have quite a lot of options. And if you're in planning, etc., and also production, laboratory, and sustainability, we actually, believe it or not, we have a HR software. So if you're interested in any one of them, please feel free to reach out through the support channel that I'll have a link towards the end, or come chat to me if you're interested in any of the other fields. I can point you to the right direction and talk to the correct consultants. So today I am sitting in the Perth office. If you're calling from the rest of the world, welcome. Thank you for dealing with the time zone difference. But I expect the majority of you will be calling from Australia. I am in Perth, so just keep that in mind. If you do want to have a chat with me, there might be slight time zone difference. But anyways, that's enough. We'll kick it off. So those of you that have potentially just joined when after I finish my little self monologue, my name is Hawkin. I am one of the senior geology consultants here at Datamine. And today we're going to be covering the Drillhole Planning tool on Studio RM. We'll kick off by talking about some of the traditional string digitization method for Drillhole planning. And then we'll jump into the actual Drillhole Planner specific to Studio RM. We'll give a quick overview of the basic navigations, how to get to the Drillhole Planner, and some of the handy hotkeys to go with it. During the demonstration portion of the webinar, I'll have the hotkeys turned on. So I'll ask you guys again if you can see me. In fact, if you can see the screen now, can someone just give me a quick reaction, like a clap or raise your hand or angry face or anything like that? Oh, yeah, thanks. Yep, we'll talk about the 3 methods of adding new holes. I won't go into too much detail for that. Like I said, there is a very in-depth discussion and tutorial on that already. So if you're interested and you want to learn the absolute basic, please refer to that video. I think Beck will have that at the end there. And then we'll dive into what you're really here for, the 4 different use cases available from the 3 different methods of adding new holes. We'll talk about adding a exploration drill holes through a color target planning method, very similar to the traditional string digitization. And then we'll talk about offsetting colors to generate a whole series of infill drilling. And then probably the most exciting part to me anyway, the open pit GC and underground GC planning with points. And right towards the end, I'll show you what some of the export outputs look like, and also how you can use that to assist with the accounting. So, drill hole planning. Why do we even bother? So my thing has decided to stop working. Oh, there we go. So drilling is one of the most effective ways of deriving geological information. It's probably one of the most important things that a project or a mine or exploration geologist will do in their career is effective drill hole design. Drill samples like chips and core are essential to mineral resource estimation. It provides some of the best data that we can from without actually seeing the rock. Most of the time we can't actually see the rock because they're in situ. Not many of us are silver surfers that we can just go into solid matter. So yeah, we do rely on drilling quite a bit. But drilling is very costly, as outlined by all these. It doesn't matter where you are, you're on the surface, you're underground. Maybe underground is a little bit cheaper, but drilling in general is very expensive. So appropriate design is crucial to accurate cost prediction and budgeting. But that itself can be time consuming, right? Unless you're a Studio RM user and you use our Drillhole Planner tool. Yeah. So how do we drill hole plan how do we plan drill holes? So traditionally we use this collar to toe string digitization method where you have a collar point and then you digitize a 2D or 3D string from the collar to the toe. It's a very easy concept. It's generally the same approach throughout different software packages, but there's a reason why only sort of generally quite experienced people do this. Graduates, although it seemed really easy to implement, it's actually quite difficult to master. So, yep, graduates, kudos to you for having a go, but don't be sad if your drill design isn't accepted by your senior from the very first get-go. It does take a little bit of practice, but that's all right. But from geo to geo is kind of similar to interp. You ask 10 geos, you might get 18 different interpretation. Sometimes drill hole design is the same. It may be difficult to reproduce from geo to geo. And also, with 2D strings, it's stationary and could be cumbersome to modify. It doesn't matter what software packages you're in. And the output is a 3D string rather than drill hole object. And it does require some workarounds to compile the total meters for budgeting input, like querying in 3D space, that kind of thing. So we have an elevated method. With the Drillhole Planner tool, it's easy to learn and easy to do, so that easy part is retained. This particular tool is specific to Datamine for Studio RM. And the nice thing about it is it's easy to reproduce from user to user and also easy to modify if you make a mistake or if you change your mind down the road. And it outputs the survey drill holes as well as CSVs for easy computation and accounting purposes later on. It's, yeah, sorry, I already said that. It's easy to compile meters and sample numbers to get your final budget number. So this is the icon of what it looks like. And in Studio RM, which we'll dive into in the live demo portion, in the live demo, just as a disclaimer, I will be doing it in RM 2.2.304, the current latest version. Studio RM 3.0, if you don't know already, excuse me, is currently in beta testing with limited release. If you are involved with the beta testing, thank you very much. If you aren't, there are some very, very exciting features that are coming in the next couple of weeks. So keep your eyes peeled for RM 3.0. But in the navigation hasn't really changed since it was first introduced with Studio RM 1, that you get it through sample analysis and go to drill hole planning, or the hotkey is PDH. First of the many hotkeys we'll use today. It will make a new Datamine drill hole object if there is not one already active in your 3D viewer, or you can select an existing drill hole to modify if you so wish. There's a couple of different fields. We won't go through all of them in super high detail, but if you do have an attribute model, you can flag the planned drill hole with geology, that kind of thing. You can determine the hole naming convention if you have a specific site protocol for it, and then the 3 different ways of adding new drill holes. And if you do want to make modification to a hole that's already in the database, you can select the plan drill hole to make changes to it. You can also determine or change the color and the ASIAN dip through the color and path field. And finally, if you have a lot of deviation data, like we do in a lot of the operational setting, and you can account for the expected deviation from the drill hole designing stages. So the 4 different use cases that we're going to go through is firstly exploration for chasing initial anomalies, either geochemical or geophysical. Is particularly handy for a long strike or down deep extension of the known trends, and also oftentimes in the exploration stage, you might have a lot of tenement restrictions, limited POWs, or even heritage issues. So your Drillhole platform might not be as easily accessible as maybe a more mature project would. And you can do this with or without a wireframe target. Use case number 2 is ResDev or OpenPit GC with slightly looser spacing requirement. If there is significant terrain relief changes, there is a built-in function that will automatically snap your colors to the terrain if you have a pickup or a DTM that's already available. You can do it without a wireframe target with this method. Scenario number 3 is your OpenPit GC, where you're typically targeting a bench, 2 benches, or a bench and a half, however many you want. Typically, they're really, really tight space, and then they are generally quite short with repeatable pattern. Bench coverage is usually paramount because you do want to delineate that ore to waste boundary. You can generally do this without a wireframe, assuming that your entire bench or your entire floor requires drilling to determine that ore waste boundary to help with your ore spotting later on. Or haulage, correct destination. We all want to truck ore to the mill instead of waste, right? And finally, underground GC. It's a concept called fan drilling. I'm sure it's not a foreign concept to most of you, but for the sake of this presentation, I'll just mention that underground drilling, both upholes and downholes are possible. And generally, you'll have limited drill platforms because, like, again, we're in situ rocks. You can generally only drill from where there's a development. So in order to achieve regular drill spacing with the expectant deviation, you do have to plan your drill holes accordingly. So yeah, without further ado, let's dive into the live demo. You should be able to see my mouse as I click. There's a circle coming out, and also when I type something in the scene there with my hotkey selection, you should see on the right hand side bottom corner. If you can see that, please give me a little thumbs up or just a quick reaction so I know it is working. Yeah, perfect. Thank you very much. So just to set the scene here, this is our demo data set. A lot of you that have seen quite a few of our webinar would be very, very familiar with this very great Viking bounty deposit. So we have a existing open pit. We've got a mineralization that we're mining with the open pit. And we have a newly defined target for the open pit extension down the line, and also with future underground development from the open pit. Holy dooly, this is a great prospect. We can do a few things. So without further ado, let's do scenario number 1. Like I said, you can do it through the sample analysis and grab the Drillhole Planning tool, but I'm actually just going to try the hotkey, so PDH. As you see down there. Note that the hotkeys only work if you are active in the 3D view. So whenever you want to use the hotkeys, just click in here anywhere. So as you can see, it's generated a new Drillhole database. That Drillhole database is currently empty. I'm actually just going to rename it to something else. Actually, let's do that later once we've actually put some stuff in it. So scenario number 1 is a very simple string digitization technique. So typically you would go, if you were to do a string color to tell, you would just do, like, let's just do one. I have a new string object here, and I can make a new string, snap to my surface here, and click from here to here, and voila, that's my drill hole. But it's actually snapped to somewhere weird, but that's all right. You get the idea. That's not a desurveyed drill hole. It doesn't have any survey data. It doesn't have any sample points. Maybe not the most useful. So here, we're going to do something very similar with the interactive pick location. I'm gonna have my color coordinate ticked on, and I'm gonna add a new drill hole. I'm going to snap to surface. Oops. Excuse me, snap to surface. So as you can see, I prematurely click over there to make it just digitize a new hole in 3D space in the middle of nowhere. If you do want to change that, you can actually change it very easily by just clicking this edit button, and then it will select a new color location. Now, you can change the design of the drill hole just by going to here. In this case, I'm going to do 60 meters, and let's do a 300-meter drill hole. And I'm going to click out of here, and I will again go back into my add new drill hole. And this time it should, let's do a ASCII of 270 maybe. It should make a new hole for me like that. That doesn't hit any target, so I can just change my toe position for my target to here. And also, I can subsequently change my drill hole length to, say, I don't know, 400 or something like that, to make sure I go through my target properly. Now, it's pretty handy if you do have that very limited drill hole, very limited platform availability, to keep the rig at the same location, but to digitize multiple target points. To do that, I'll have to tick on my target. I'll untick this edit button. I'll come back to my add new drill hole, and I can just digitize it anywhere I want. And now I have a pretty crazy surface drilling design that are generally quite long. So similar to a standard string digitization technique, you can query the total drill hole length or the number of drill holes in the 3D scene. The quick key for that is QMD, or query multiple holes. It will spit out your output down the bottom here somewhere. The total length is 2000 meters. That's a pretty standard ResDev or exploration program, and I do have 7 holes. So that's scenario number 1. We can save that drill hole as, let's call it Viking Bounty Exploration. And now it's saved. So I'm going to make a new drill hole database for the ResDev scenario. So we're moving on to use case number 2 with an offset color. This is probably most useful for sort of looser space infill drilling. Notice that my new drill hole name hasn't actually changed. Is because when I first opened up the drill hole planner, that VBEX drill hole was called the new drill hole, so I can update that just by reopening it again. Things do work via the memory, so it does get committed to memory pretty frequently. So yeah, the new drill hole that I'm on now is the one I will be digitizing new drill holes into. So something I didn't change earlier is this hole naming prefix. So let me fix that. So this time we're going to do a ResDev drill program. I'm going to do a offset from color target method, but I'm actually going to define my topography surface. In this case, I will start my drilling up in this pasture here, assuming that I have the correct tenement for it. I'm actually going to start with the same method as before. I would define a series of holes that are generally correct. Actually, let's think about this. Let's do a hypothetical target for this dip that we're doing here. So before we do anything, let's do a section by 2 points, and we'll just extend that that target there. You see, go into section view, go on here. I'm just going to draw a quick box and extend my drill target down dip and along strike, COO. If you didn't know already, the string in Datamine Studio RM, if it's closed, you can actually fill the center of the string to make it look like a surface. It's not actually a surface, but it is pretty handy for visualization purpose. So now I have a surface that I can target. I can probably design my drill holes a little bit better. So I know where I want to start my drill pattern from. I'm gonna drill generally 60-degree holes, which is not an ordinary for most RC drilling. And because it's an RC hole, I'm gonna have a sample length of 1 meter. That's also not unexpected. I'm gonna drill generally northerly holes. Sorry, put it in plan view. So north is up towards the top. And yeah, let's put a hole right there. So I've got my 300-meter hole. Oops, scusi. The screen share, sometimes it's a little bit tricky. I can adjust my drill hole length to something a little bit shorter, a little bit more appropriate, because cost is very important. And now that I've digitized my very first hole, I can offset my drill hole from that position. I'm going to offset it south, and my resdev spacing is 50 meters. Yours might be 160, it doesn't matter, you can change it there. And I have my first location turned on. I'm snapping to my topography service. I can just go add new drill hole, add new drill hole, add. And yeah, so I've got 5 drill holes, and now I can turn it 90 degrees and come one to the, I don't know, depending on your perspective, to the east. And then once I've done that, I can go back to 0 degree ASI, and then I can do the same. And then turn it again, go 1. Oop, I'm actually gonna go south. So notice that all of them will be the same length. With the offset color, the existing design will be carried on to the next. That's the default behavior. You can just subsequently go into each of the individual holes and then change that. So let's do 300. And yeah, there you go. There's our second scenario right there. And this one is VBRD. Cool. So yeah, I realize that's probably not new to most of you, and I do apologize if it is a little bit boring, but this next part is what I really do want to show you with bulk points. So say we want to plan a whole bunch of GC through here. I can separate that from the topo or my pit pickup with a string. So I'm gonna first digitize a horizontal section through there and just check that my sections actually worked. And I'm actually gonna draw a single section through the hotkey CSL. It's gonna bring up my section string tool, and the surface that I want to draw a single section on is this surface triangulation on my topo. I'm gonna digitize it at horizontal, and I'm just gonna chuck it into a random object called section. So once that's done, I'll hide all my what that's done is draw a single planes through the position that I've digitized my section onto, and basically cut a line through there and then put an actual string object. So as you can see, it's generated something a little bit extra. I don't need that. I can just delete that as well. And now I can separate my pit floor from the rest of the triangulation. I can do that through SPBS, or split by string. Now that I have a closed string, I'm going to generate multiple new objects. It's going to have an inside and an outside. And from there, I can turn off my original, and now so the outside looks like that. Oh, sorry, the inside looks like that, and the outside looks like that. With my pit floor defined, I can now generate a series of points that are regularly spaced. So I will go into plan view and I will go with a regularly spaced grid points. So the shortcut command for that is GRD or grid DTM. I'm going to say my GC spacing is approximately 10 by 10, and I'm going to use the inside or the floor that I've just isolated from the topography or pit pickup. In this case, I'm going to use the highest surface. So what that's going to do is put a point at the highest part of whatever triangulation that you've just defined. So I'm going to do that. It's going to give me a bunch of regularly spaced, in this case 10 by 10 meter space points. And now I am ready to plan some drill holes. So PDH again. It should make a new drill hole for me because I didn't have anything selected before. And now I'm going to call it VBGC. You don't always have to start with one, but I'll just keep it at one just to show you how many drill holes we can actually plan in a very short period of time. So with most GC, especially open pit GC, the dip is predetermined or is quite commonly the same. In this case, my mineralization is dipping to the south, so I'm going to drill to the north. So as east at 0 is okay. I'm going to drill, say I have 20 meter benches. I'm going to do 2 benches plus 1 just to be sure. And in this case, we're going to do from selected points, and with the color coordinate ticked on, I'm going to take this interactive color location selector. I'm going to select my points first, and then I'm going to tick on this color selector. What that's going to do is tell the drill hole planner that I want drill holes to come from each and every one of these points. I'm going to hit add new holes, and it's going to go nuts. The magic window is running. It's planning a whole bunch of 60 meter drill hole at 60-degree dip towards 0 or due north. And that's done. It's just planned 975 holes for me in a matter of, I don't know, however long it took me to ramble through that bit. And I can turn on the rest of my triangulation, and hey, it's actually done a pretty reasonable job. Flotation center, change that. There we go. So there is your GC scenario. Let's go and save that as BBGC. And finally, for my underground friends, more often than not, whoops, don't need the points anymore. So the idea is the same. You want to generate a bunch of regularly spaced points along your mineralization, or more or less your pierce points. More often than not, you already have some. By the time you get to the underground stage, you already have some of the drilling. So maybe you want to infill it. These are 50 by 50 meter drill space. So maybe I want to infill it to say 25 by 25. I'm going to align it to the plane that's most representative of my pierce point. In this case, I'm going to use these because they're easy. They're a demo data set for a reason. I'm going to just set a section through here. And if you don't already know, whatever view you're on, you can set that as your active section through ASX or align section. When you turn on the grid, it's going to show you what view you're looking at. And if you rotate away, you can go back to it through AVW. So now I've defined my active section. Let me just turn that off because that's super distracting. Again, I'm going to do my GRD to generate a series of grid points. In this case, I'm going to do 25 by 25. And I'm going to select my underground mineralization envelope VSOR. And I'm going to put the points in the middle of the closed solid. If you have just a single surface, generally you would just use the highest, or the lowest will put the point on the footwall, on the footwall side of your triangulation. So I'm going to go average, just so I put it in the middle. And I will make the points a little bit bigger and uglier so everyone can see. Let's go 3. And let's do a fixed color. Green, how about that? And if I turn my wireframe a little bit transparent, or very transparent, you can see that I've just digitized a whole bunch of points on that plane at 25 meters apart. So now I can see that I've got some drill gaps in here. I can come in and select these drill gaps and digitize the drill holes through it. Again, new drill holes, I'm going to do from selected points. In this case, I'm actually going to define my color coordinate first from my drill hole platform. So let's go to platform number, I don't know what this is, 4 or 5. I'm going to snap to the face as realistically as possible. You should see that my coordinates have changed, and I can turn on my target and now. Just a reminder before, instead of choosing the targets, we chose the color for the OPGC example. In this case, we're going to set the points as target, and I'm going to just swipe in a bunch of target points. Why is that so small? Let's do the swipe selector. Let's do these ones and maybe those ones there. Yeah, you sort of get the idea. Not perfect, but you can also add in a few of them. Oh, not a drill hole. Let's do that and that. Not that drill hole. Oh, geez. It doesn't matter. It won't care about those drill holes. But I'm going to tick on my select target location as the interactive. So now I'm telling the drill hole planner, please plan a bunch of drill holes from that color point that I've just specified to these pierce points. For underground drilling, generally you want to go beyond the mineralization a little bit. So I'm going to go 20 meter over drill. And I'm going to hit add new holes. And here's my fans. And hopefully, let's turn off that topography and open pit. So hopefully it's done what I need. It's a little bit ugly, so I'm going to Control Z it. Whoops, no, Shift Z, Control Z. I'll get rid of all my drill holes, and I'm going to redo that. Let's do it here. SDS. I've defined my color from there, and I'm going to come back and select a whole bunch of points again. Make them my target, add new drill holes. That's a little better. So again, you can fine tune those as needed, but generally they poke out of the footwall a little bit, and yeah. So my underground scenario is done. I can save that. Now it's saved, and you can bring that back in and modify it as you wish. But also, if you haven't used it, you can actually import this as a whole bunch of CSVs as well. So VBUG down the bottom here, I'm going to save them to tables, and I can go VBUG save. It's going to save it to my Active Directory here, so I can come into my project datasheet, and it will just take me to the containing folder. Oh, it's opened up on my other screen, so bear with me while I bring it up to the share screen. And there we go. So I have my color, which is probably the most useful for budgeting purpose, because it'll tell me how many drill holes I have and how many total meters. And if you're an Excel whiz, you can just easily go, I'm going to sum up my meters. And then you can send the spreadsheet to the accountants, and then they can build you a super awesome macro that calculates all of this. And you can also figure out how many drill holes there are. So yeah, that's the gist. Yeah, as we just saw, you can export it, bring it into Excel, do whatever you want, and hopefully it helps with tallying up the numbers and getting the money sign at the end. So yeah. So we've just gone through the 4 different scenarios with the 3 different usage, interactive drill hole digitization for exploration, offset drill holes for your sort of ResDev / looser space GC. And then probably my personal favorites are the drill holes from multiple points for GC colors and from multiple points for underground pierce points. And that's it. I've been Hawkin. I apologize. It went a little bit longer, but if you want to reach me, my email is on here, or you can alternatively reach out to us via the support channel, support@dataminesoftware.com.